In this tutorial, we will show you how to monitor a rotating gear in mesh having a damage on one of its gear teeth using our ibaInCycle expert module. Therefore, we'll first have a look at the simulation data. What you see here is the load signal of a gear with 25 teeth. One of those teeth has a damage, which is clearly visible in the time data. The rotation is a periodic movement, and we have a trigger that indicates the period of the gear. This trigger could come from an incremental encoder or from the information about the input speed of a gearbox and the transmission ratio to the gear. With this information, we can feed our ibaInCycle expert module and it will display the gear signal within one cycle. In order to do so, let's go to ibaPDA and have a look at our settings. As always, when we want to configure PDA functions, we go to the I/O manager. Here we already created an ibaInCycle expert module. Our input signal is the load signal of the gear. The cycle pulse trigger defines the time period of one rotation of the gear, which we named key phase. We will now have a closer look into the profile settings of the module. Note that this is now an ibaInCycle expert module instead of auto-adapting. This means we only calculate, we have no teach settings anymore. What we want in this case is just to monitor the single bands or gears and not a whole curve. We have 25 gears and we want to monitor every gear individually. So we divide our cycle into 25 bands. We want to have 10 points within each band, which makes a total of 250 samples per cycle that will be taken into account for the calculation. Furthermore, we are interested in monitoring the range of every band or gear. This means when this is our gear signal, we are looking at every difference between maximum and minimum of every band. If we have a damage on one tooth, its range would exceed the range of the other teeth. As after every cycle a new cycle follows immediately, meaning we have no pauses anymore between the cycles, we can use a pulse trigger indicating every new cycle. Let us now see what happens when we start the acquisition. In blue we have our gear signal and in red our digital cycle trigger. Under that we see the ranges of each band. Here we can also clearly see that this band is significantly higher than the others. This is band number 21. On the right hand side we see our cycle view, where you can also see that here the range is higher than for the others. The waterfall plot is another depiction showing that the range of tooth number 21 is higher. So we discovered that the range of the 21st tooth, counted from the position of our trigger, is higher than at the other teeth, which indicates a failure of this tooth.